Hi everyone, my name is Juning Hu. I'm the founder of Coach.ai. Today I want to share the topic on the science behind the ChatGPT. So let me first share my slides. So everyone is very excited about the ChatGPT, and probably all of you have already tested the different function of ChatGPT. And it looks almost like magic for people who don't study AI or who are outside this field. So today, first, I would like to demystify this technology for all of you. I have been working in this field for more than 20 years. So I just want to try to use some plain language so that everyone can understand what is exactly ChatGPT. So first, to give a high-level overview for ChatGPT is you can think about the ChatGPT is essentially a deep neural network, and this neural network has input. And let me actually explain a little more what we mean by a deep neural network. So a deep neural network essentially is a big function. So all of you who study computer programming, you give a computer program input and you get output. So in a neural network, essentially is an algorithm that has many functions inside. It has an input layer and it has output layer. In between, there are many hidden layers. When we say deep neural network, we always refer to the case where there are many hidden layers. So here, for this neural network, the important part is the neurons. The neurons are the representing what the computer perceives, and the output is what the outcome it generates. So for ChatGPT case, the input would be each node would represent a token, or you can say a subset of the token. Then the output is the word it generates. That is a high-level view. And a neural network can also be applied to other situations, like we want to use this to classify a disease. So the input could be the blood pressure, the glucose level, the weight, and other numerical information. And the output could be 4 different types of disease. So in this case, the second disease, 0.6, has 0.6 probability. So it could be this person has a heart condition. So this is a very high level general understanding about the neural network. And one of the important part in the neural network is the weights. So here the weight is show the 1, 2 weights, and all these links are the weights. Essentially, what we are learning, what ChatGPT is learning, is those important weights. So those determine what output will come out. In the case of ChatGPT, the output layer has more than 30,000 tokens, each corresponding to one of the words it generates. So when the ChatGPT takes the input, a user sequence of words, it will generate the select one word first, generate that word, and then generate the second word. So it generates a word one by one. So that is how, in a high level, how the ChatGPT works. Now, in a more specific level, if we want to understand the architecture of ChatGPT, is that it's based on so-called transformer architecture. The transformer architecture is a special type of neural network. It first is feed forward, meaning it goes from input to the output. In certain other type of neural network, for example, the recurrent neural network, the arrow can go from the input and back to itself, to the hidden layer. The same hidden layer can go back to itself. So that's why it's called recurrent. So in our case, the network direction is very simple. And then in this neural network, we have 2 types of layers. One is called the encoder layer, another is called the decoder layer. The encoder layer encodes the input, and the decoder layer take what's coming out from input or from the encoder, then generate output. So on the left, you can see this is a standard view as I showed earlier. But on the right, it's the same neural network, but it flipped. It rotated 90 degrees, so the input is at the bottom and the output is at the top. And this make it easier to describe the neural network if we want to have more layers to show in a paper. So this is just a convention where people nowadays show the neural network from bottom to top. You can imagine that is exactly like the same picture on the lower left corner. So what is inside the encoder and the decoder layers? In the encoder layer, we have two sublayers. One is the first sublayer is called the attention layer, and the second sublayer is called the feed-forward layer. The attention layer is the core technology for transformer, and it actually started the NLP revolution. Because before that, it's very hard to capture the sequential information inside the language input. So by using attention, we actually can attend to the word before the current word so that we can capture the sequential information. And the second layer, feed-forward layer, is is a standard layer, as I showed earlier, just a layer of neurons that has connection with the previous layer. So this part is very straightforward. For the decoder layer, it has one extra layer in the middle. It's called the encoder-decoder attention. It attends to the previous attention layer, and also take the output from encoder as one of the input. So this is what we know inside each encoder and the decoder layer. But for simplicity, today's GPT and many other large language model only use decoder layer. The early days back in 2018, 2019, people still use encoder like a BERT, but it's purely based on encoder. However, if you want to generate words and actually generate specific language tokens, it's better. We have to have decoder. So decoder is an essential part of generating text. The encoder part is mainly for classification. Now, in the decoder layer, what we would like to look is so-called GPT, because ChatGPT essentially is based on the first GPT model. The GPT stands for Generative Pre-Training. And here, generative basically refers to the output of this model is a text token. That's called generative. Now, the token could be corresponding to one of the words in the dictionary, or it could also be a neuron, a symbol like 1 or 0 that indicate a classification task. So as you can see, the first version of GPT has 12 stacked layer, identical layer stacked on top of each other. And inside each decoder layer, we have we call masked multi-self attention. Essentially, it's attention layer, but the word only attends to the word happened before, not after. So it's one directional. That's why it's called a mask. You mask the remaining word it hasn't seen before. The second feed forward is the same. And then you can see there's a plus sign where it goes from the input to the output after the attention. So after you transform through attention layer, then you add the original input back to the output. The reason we do this, this architecture is called a residual network. The reason we capture the residual is that it helps us to actually get the original input and not let it lose over time. This helps us to do back propagation in the neural network. So for neural network, when we update the weights, we back propagate from the final, the last layer, all the way to the first layer. In doing so, we take a derivative. Essentially, the back propagation is based on the derivative of each layer, the function of each layer. If we don't add the input from the previous layer, after many transformation, the function transformation, what's remaining to be updated in the beginning layer will be very small, and we call this a vanishing gradient. So it's very hard to update the neural network. By keep the original input add back to the output, we can get a derivative. At least there is a one unit derivative from the original input. So we don't have a very small number there. So that is the residual network reason why we use that. For now, we have for this decoder, it has 100 million parameters. And we can see this is already very big for that time. But it actually not that big today in today's standard. And one thing I want to mention in the GPT model is this so-called layer normalization. It is a transformation of each layer to normalize it based on the current layers, the aggregated sum of current layers. So you convert the number between 0 and 1. So that's a normalization. It helps the convergence faster. Now, when we talk about representation of words, how do we convert a natural language to send it to a neural network? It's easier to understand that the neuron takes some numerical numbers and then we do numerical operation on the neurons. But what if it's a word? How does a neuron, what number do we give to the neuron? A simple way, very simplistic way, is to convert each neuron into an index of the word. So if the word is index 99, the first neuron should have the value 99. However, this would create some bias because yes, our input can have, say, 30,000 neurons, each corresponding to one word, but the numerical value could create a problem. Some numerical value are much larger than the other. So in order to make all the neurons equivalent, have the similar weights, we actually make each neuron, we convert a word into a vector. So in this vector, we only look at the position that's corresponding to the index of the word. And for that position, the numerical value is 1, the rest is 0. So we call this vector representation called one-hot vector, one-hot representation. As you can see, this vector size totally depends on our vocabulary. So if we have 50,000 unique words, our vector size should be 50,000. And as you can imagine, it's a very big vector. If we have many words, the computer requires a lot of memory to remember each, to basically waste a lot of space to memorize each different word. So instead of using such a one-hot representation, people come up with another representation of word, which is a much smaller vector. So this vector could be only maybe 200 or 300 wide, only 300 elements in the vector. And this vector actually can capture the information about that word. So that is kind of very interesting. What people find that this is essentially mapping a word to a hidden space where you can have much more compact representation of a word. So what we discovered that once we map the word to a smaller space, in fact, we can actually discover the relationship between words. So for example, here, fight has a longer distance to love than to kill. And the people also discovered like London is very close to Paris, then London to like a general word like Monday. So, and then you can also do word operation in this hidden space. For example, the king of British, the king of England is similar to the king of France. And when you do the like minus or plus operation after they each operate of each other, then the actual distance is very similar. And so people find this interesting mapping, and this allows us to capture the relationship between words. So we call this dense representation. It's a dense vector because it's smaller. We call it a word embedding. And that is give us the understanding about what goes into GPT-3. And the same thing, we also want to encode the sequence of words. So the way we encode that is using position. Now, how do we send this position to the neural network without like a bias 1, 2, 3, 4 using the numerical value? So we do the same thing. We convert that into when converted into a small vector, and that size of that vector is the same as the word embedding. So as you can see that we can then add the word in vector with the position vector. And essentially they are called the text embedding and the position embedding. When we add them up, we send the outcome, the sum, as an input to the GPT. So that gives an overview, essentially from NLP viewpoint, how we represent words. And you can see GPT-2 has a little slight different architecture from GPT. In GPT, the layer normalization happens after each main sublayer, like attention and feed forward. In GPT-2, they do layer normalization before, and basically it's normalize the values. And the rest is the same. And of course, GPT-2 is larger. It's twice larger. Then we go, by the time they invented GPT-3, it becomes significantly larger than GPT-2. In GPT-3, the architecture stays the same as GPT-2. And now the major difference of this GPT, not only they become larger, and also they require much more training data. For the first GPT, you only use 7,000 books. The GPT-2, we use the 80 million documents, 40 gigabytes of text, and all crawled from the internet. And they cleaned them up themselves. In the GPT-3, we have way more data. As you can see, not only the web text is a newer version, we have more books, we added Wikipedia, we now have a much, much larger web document called Common Crawl. Common Crawl has 410 billion tokens. It's the largest data set among all the data set. So that's where the power of GPT-3 came from. And I want to give you this high-level timeline to understand the development of ChatGPT. And as you can see, Transformer happened in 2017, GPT happened in 2014, then GPT-2 2019, GPT-3 2020. After that, in 2021, they applied the GPT-3 to GitHub code. So they trained on all the GitHub code to allow the model to generate code, programming code. So if you train on Python, it can do Python programming, it can do C++ programming, and the instruction essentially is the human instruction in those GitHub code. And then there is another thread of development which contributed to the ChatGPT success. So even though GPT came out in 2020, and then OpenAI released the API in end of 2021, it hasn't generated much buzz because the public doesn't, there are two reasons. One is the public doesn't know how to talk to GPT-3, which is in the backend. Second is the accuracy and the usability of GPT-3 is not that ideal. So in comes a new method that is using reinforcement learning to improve GPT-3, and that achieved a very good performance, and that's called the instructGPT. So in order to understand instructGPT, we have to understand the basic of reinforcement learning framework. So in the reinforcement learning framework, we have three things to worry about. One is the state, what is the current situation. Another is action, what I can do. The third is reward, how the system reward me. And the agent is trying to optimize, maximize the total discounted reward. So based on this, we can build a neural network, try to learn what to do in every situation. In our case, the policy network, we call this a policy network. Essentially, in our case, we are trying to learn how to generate a word based on all the inputs, the sequence of words. So our state is the sequence of words. Output is one single word. And the GPT basically generates a word one by one after one another. Each time it only generates one single word. So it selects action. Its action is one of like 50,000 possible actions it can take. So for instructGPT, I want to talk about this main step. The first step is get a human to label, to generate some answers. So this is purely human-generated data. We feed this data to the GPT-3 to continue to train the GPT-3. This is called supervised learning. In the second step, we allow user, let GPT generate several answers and let the user to rank the answer from good to worst. Then that's a numerical reward. We use that numbers, the corresponding ranking numbers, or some numerical number to represent the ranking, and feed that as a reward to build a reward model. In the third step, once we have that, we can also optimize, use this reward to train a policy function to tell the GPT what to generate. This policy function essentially is our instructGPT model. And this model, for this reward, the policy function, the input is all the users' prompt plus examples plus the questions, and the output is the tokens. So it generates repeatedly until the user, until it reaches the end of a token symbol, so it doesn't generate anymore. And as you can see, instructGPT significantly outperform GPT with even a small size, 6 billion parameter. It performs better than the original 175 billion GPT-3 model. So it's very exciting. And finally, the ChatGPT is built on top of instructGPT with some additional dialogue data. That the dialogue data are designed by the humans. So that is my major talk about the science behind the ChatGPT. Finally, I just want to talk about my company, Coach.ai, and you can go check it out. And if you have any question, I'm going to skip the illustration of our technology. But if you have any question, you can reach out to me at Junning at Coach.ai. Thank you. Bye-bye.